If you are trying to add more reliability, more uptime to your network by adding more than one internet service provider, you will need policy-based routing. In this video, I'm gonna show you how to configure it from scratch in RouterOS 7. Welcome to the network trip. Before going to the configuration, let's look at the diagram that we have today. It's a pretty simple topology, just a single router with two internet connections. One from ISP1, the second one from ISP2. There is one cable that is going to one switch where we have all our internal users connected to. So the idea here is that we can create groups of users, and when we can define what will be the provider that they will use when they are sending traffic to internet. For example, we can say this user is gonna go through the ISP1 and this user is gonna go through the ISP2. As usual in the channel, we'll go from scratch, one step at a time. So I have prepared this process that you can see on your screen now, and we'll go one step at a time. At the end, we'll be able to manipulate the routing table and we'll decide which users are gonna go through the ISP1 and which users will use the ISP number 2. So let's go one step at a time. So at this point, I have just a router, no configuration on it. So I need to go to that device and we'll start with the step number 1. So we'll start by configuring the WAN interfaces. So we can see here that we have two interfaces, Ether1 that is connected to the ISP1 and Ether2 that is connected to the ISP2. The ISP1 is on the network 172.16.255.0/24. .1 for the ISP's device, .2 for our mikrotik. Then for the ISP2 we have the network 200.10.20.0 forward/24. Again, .1 for the ISP, .2 for our mikrotik. So let's go to the configuration. So we are in step number 1. So I have the Windows here and I have access to this device. To configure the WAN interfaces, I need to add the WAN IP addresses. So I need to go to IP addresses, and then I will add the IP for Ether1 and the IP for Ether2. If we remember the diagram that we have over here, Ether1 is gonna have the network 172.16.255.0/24. So I'm gonna add a new IP address. I will pick the interface Ether1 172.16.255.2 forward/24. You can see that just to have access to the device, I have added the Dxp client. So basically I'm just going to remove that one. And I can relog in by using the new IP address. Now I'm in the router by using the newly configured IP address. So we can see this is the ISP1. Let's add a comment to this. Now I need to add the second IP address, the one that is connected to the ISP2, 200.10.20.2/24, interface Ether2. So we have those IP addresses already on the interfaces. This is the ISP2. As a good practice, I always like to create a list for all the WAN interfaces. So we can do that by going to interfaces and then interface list. Here in this bottom list, we can create one list, for example, and then we can simply add all the interfaces that are with this role. So interface 1 will be on the 1 list. The same applies to the interface number 2. Step number 1 is done. The next step is configuring the LAN interface. So if we check the diagram, we have the network 192.168.50.0/24. We'll use the IP.1 in the interface in R1, and then we'll enable a Dxp server. So those devices that I have underneath will be able to take a dynamic IP address. So let's do that. We can go to IP addresses, and then I add an IP address to the interface Ether3. That is going to be 192.168.50.1/24. And this is going to be local area network. So we have ready that IP address on the LAN interface. Now we can add a Dxp server. First of all, I will add a DNS server to the router itself. So I'm gonna use the one from Google. You can use your own DNS server at this point. So we'll click OK. And now we can add a Dxp server on the LAN interface. That is under IP, then Dhcp server. The tab number 1, Dhcp setup. And now we'll pick the interface where we want to install the Dxp server. So in this case, it's Ether3, the LAN interface. We'll just follow the steps in the wizard. We'll increase the list time to 1 day. And now we have a Dxp server ready for our local area network. Just change the name here. Now we have Dxp on the LAN interface. So basically at this point we have the WAN interfaces and the LAN interface ready to go. The next step, the NAT configuration. So if these devices in the LAN network are gonna send traffic to internet, we must enable NAT. If the local area network is trying to send or receive traffic from internet, we'll need network address translation or NAT. Basically, the idea here is that if these devices are generating traffic, the traffic will hit the router. And then when the router is sending out the traffic to ISP1 or to the ISP2, then we are going to change the source address by the one that is in those WAN interfaces. So for doing that, we need to add a Nat rule. So that is under IP, then firewall, and then we'll go to the second tab, NAT, and we'll add a new rule. For those with no experience in mikrotik firewall rules, basically here the idea is that we have several tabs where we'll set all the conditions that must match in one packet, and then we'll apply an action. So in this case, the action is going to be changing the source address, and there is an action for that that is called masquerade. But the condition is that the traffic from the local area network must be leaving the router out of Ether1 or Ether2. If you remember, we have a WAN list that already has those two interfaces as members of it. So we're going to use that list. So the chain is going to be source NAT, and then we'll go to out interface list, and we'll select the list that we created recently. So basically here we are telling if there is traffic that is leaving out of any of the interfaces in that list, then we'll apply an action. Which action? The one that will define under action, and that is going to be masquerade. So masquerade is going to go to IP addresses, and it's going to pick the IP address that we configure on Ether1 or Ether2 depending on where the traffic is leaving, and it's going to change the original source IP, but that IP on Ether1 or Ether2. So the logic behind this Nat rule. So you're going to say Nat internet. And we can see that now we have completed the step number 3. So now we need to create routing tables. So the idea is that we'll have groups of users, and we'll define which ISP that group is going to use to send traffic to internet. So in this case, we can have 2 routing tables. One can be to ISP1, and the second one to ISP2. And we can complete this step easily just by going to routing and then tables. You can see that by default there is one table that is called main. So this is the main routing table. But now we need to add two more routing tables, one for the ISP1 and the second one for the ISP2. So I'm gonna add the first routing table and the name is just gonna be to ISP1. I will click forwarding information base because I need to use that routing table. And I click OK. I'm gonna add a second one and that is gonna be to ISP2. And again, I need to enable the FIB, forwarding information base. Now I have two additional routing tables that I can use to send traffic for the groups that I will create in the next step. The next step is marking the traffic. So in this case, we can say, for example, this computer is gonna use the connection going to the ISP1 and the second computer is gonna use the traffic going to the ISP2. That is basically the magic behind policy-based routing. So how are we gonna mark the traffic? To do that, we'll use a structure in mikrotik that is called the mangle. So if I go to IP, then firewall, and then mangle, here we can start adding rules. Again, we have a set of conditions, and then we apply an action. The mangle in firewall in RouterOS is basically to mark traffic. We can add what is called a routing mark. That is basically a label that is added to the packet, and then we can identify those packets to be routed using the routing tables that we have created. Let's go with the first group of users. So if I add a new entry here in the mangle, I have this chain pre-routing. So basically, this rule is going to be applied when the packet is hitting the interface in the router, just before any other processes in RouterOS. You can see that we have several conditions in this packet, but at this point, we'll be creating groups of users based on its IP address. So for example, I can say the computer 192.168.50.100 is gonna use the ISP1. Or I can say the computer with IP 192.168.50.200 is gonna use the ISP number 2. That's something that we can do, and we are going to test. And we'll learn how to do that now here in this mangle rule. So we can see that the chain is pre-routing. Then we have the source address. In source address, we can specify a single IP address. We can specify a network address. But in this case, you can see that we are limited to only one entry. Probably we are going to add multiple IP addresses. So instead of using source address, we can use an even better matcher that is called source address list. So that means that we can create a list with all the IP addresses, with all the networks that we want to send out of the ISP1. If I click here, basically now I don't have any list available, but I can only type, for example, clients to ISP1. So basically this is going to create an empty list with the name clients to ISP1, and then we can start adding IP addresses to that list. I'll keep the name clients to ISP1. I will go back to the general tab. If we check our diagram, the local area network will be generating traffic. The traffic will flow through the switch, and then it's gonna hit the router in the interface Ether3. So that means that from the perspective of the router, the traffic will come in Ether3. So we have a condition here that we can add. So all the traffic that is coming from the LAN in the interface Ether3 and belongs to the list that we have just created is the one that we need to apply this action. So I'm going to add a new condition here in this window. So in interface, that is going to be Ether3. Pre-routing traffic coming in Ether3 with a source IP address that belongs to that list, then we'll apply an action. If we go to action and we check the available actions, there is one that is called mark routing. So basically it means add a label to that packet, because this packet matches the conditions that we have specified for this rule. So let's pick mark routing, and you can see that automatically I'm getting the field new routing mark, and if I expand the list, I will see the routing table that I created before. So in this case, I want to send this traffic to ISP1, so I'm going to add that label. So at this point, this is not going to send the traffic through the ISP1, it's just going to add a mark, a label to the packet, and then we can use that label later in the routing table. Then we have pass-through. So if I disable that, basically when the router gets a packet that is matching, this entry is going to stop the processing. That means that it's not going to check the remaining rules in the mangle. So I want to do that. So we'll say pass-through and then OK. If we think that rule can generate some problems if, for example, we have more networks in our router. So let's say, for example, that the interface 4 has a different local area network. If that PC is sending traffic to R1, R1 is just verifying if the traffic is coming in Ether3 and is checking the source IP, and is gonna add the label to the packet. But we are just trying to target the traffic that is going to internet. So probably we need to add more conditions to that rule. And those conditions can be, for example, if the packet is coming from the IP in that computer in the interface Ether3 and is going to a public IP address, then we are going to mark the packet. We know that there is a list of private IP addresses. So basically we can create an address list with all the private IP addresses. And if there is traffic that is going to an IP different than a private IP address, that means there is traffic that is going to internet. So we're going to mark that traffic. So let's check that. So we can add one more condition to that rule. So let's go here to address list, and I will create a list that is going to be private IP addresses. And I will add all the private IP addresses that have been defined in the RFC 1918. So the first one, 192.168.0.0/16. Next one, 172.16.0.0.12. And the next one, 10.0.0.0/8. So basically this list has all the private networks. So we can use that list. I can say, if the traffic is coming in the interface Ether3 from devices in that list and going to IP addresses different than private IP addresses, then we are going to mark that traffic with the routing mark to ISP1. Let's check this symbol. So basically that means no. So if the traffic is not going to a private IP address and is coming from those IPs, then we'll apply that action. And this is how now we are just targeting the traffic that actually is going to internet. I will add a comment, PBR to ISP1. And now we can simply copy that rule. If I copy the rule, I can just change the name for the source address list, and then the action is gonna set the routing mark to ISP2. Apply. I'll update the comment, and now we have two rules: PBR to ISP1, PBR to ISP2. But at this point, the list for the clients going to ISP1 and 2 is empty. So we need to add some clients. If you remember, we have enabled the Dxp Server on the Lan interface. So in my case, I'm using two computers. Those are two Docker containers, and they have a Dxp client on them. So if I go to the first computer, IP address, so we can see that this computer has the IP 192.168.50.253. This is the MAC address in that device. If we go to the router IP, the Dxp Server, and then leases, we can see that this is the first computer. So we can reserve that IP address to make that persistent to this device. So I'm just gonna click in that entry, make it static, and now this computer is always going to take the same IP address. To do that, I'm going to IP, firewall, address list. I will add a new entry, and then I will pick the list. Clients to ISP1. And I will add the IP from this device, 192.168.50.253. So basically now I'm telling this IP belongs to that list. And here we can start adding several entries. For example, I can say this is a non-existing computer, 200. Additionally, we can add a range, for example, 192.168.50 from 10 to 192.168.50 to 50. So we can see that we can start adding multiple entries. All those IPs belongs to the same address list. The rule that we created here is targeting all those IP addresses. I'm gonna add a new entry. The list is gonna be clients to ISP2, and then I will add the IP in the second computer. And I will click OK. So we have some IPs and the list for the ISP2, and we have some IPs in the list for the ISP1. So that means that the step number 5 is complete. So now we'll go to create the routes. So basically we need to use all those labels that have been added to the packets, and the routing table is gonna send the traffic to the appropriate gateway. So let's see how that is gonna look. So basically we only need to go to the IP routes, and from here we'll add some default route. The first route will send traffic to the ISP1. So add a new entry, destination address, all zeros, gateway, that is gonna be the IP that is in that interface and that network. So that is 172.16.255.1. Then routing table. So there we have main by default, but in this case all the packets that have a label to ISP1 are the ones that will be used in this route. So if I go here, then I will select to ISP1. Basically here we are just telling if there is a packet with a routing mark to ISP1, please send those packets to the gateway 172.16.255.1. And now we can click apply and OK. So let's add a comment here, PVR ISP1, and we can add a new entry. This new entry is for the traffic that is going to the ISP2. Again, .1 is the IP, so 200.10.20.1, and the routing table in this case is gonna be to ISP2. And then, okay, let's add a comment, PVR ISP2. So now we have two routes that are sending the traffic based on the routing mark. So let's check if this is working. We can check by going to the first computer, the one that is gonna use the ISP number 1, and generate some traffic in that device. So I have that computer here, we have Mozilla over here, then we can play a YouTube video. So remember that in this virtual environment, I don't have a license installed on the mikrotik devices, so the limit is gonna be 1 megabit per second in every ISP. So as you can see that all this traffic that this device is generating is traffic flowing through that interface. But the limit is just 1 megabit per second because of the license issue. So I'm gonna close this browser, and now I'm gonna go to the second ISP. If we go to mikrotik.com, you'll see that this traffic is going through the interface Ether2. So we are sending the traffic out of that interface. Again, we have a limit of just 1 megabit per second, but now we can see that PC1 is going through ISP1. And PC2 is going through the ISP2. There is something else that we can do to improve the performance and reliability, and that is to configure a failover. If we go to the routes, if the ISP1 is going down, basically the traffic from those users will go down. So instead of doing that, we can simply copy that rule, and then we can set a higher distance, and we can specify the gateway for the second provider. And now in the comment, I can say backup PVR ISP2. So basically this is a backup route. If the main route is not working, then that is gonna be active. And to verify if that gateway is up, we can simply enable this option, check gateway. If that gateway is going down, then the route will be disabled, and then the second one is going to be used. We can do the same for the ISP number 2 as well. So basically I just need to copy, set the distance to a higher value, and then set the gateway from the first ISP. And now we have a backup for the PVR ISP2 as well. So those two are the backup routes. Those two are the main routes. If you remember, this router has 3 routing tables. If I go to routing and then tables, we have 2 ISP1, 2 ISP2, and the main routing table. So at this point, all the traffic that is generated by the route, or traffic that is coming from IPs that are not on the list, are gonna use the main routing table. And we don't have a default route for the main routing table. So our idea is to add a default route for the main routing table. So in that case, the routing table is just gonna be main. So let's say, for example, that the ISP1 is gonna be the main provider, and the ISP2 is gonna be the backup provider. So again, I need to enable the check gateway ping to monitor if the main provider is up. If this is going down, then the backup default route will become active. So now we have a solution. We have tested that those clients are going to the appropriate provider. We can test the failover as well. So you remember this computer is using the ISP number 2. So you can see the traffic is going through the ISP 2. So what happens if this ISP is going down? So for example, if I disable that interface, we can see that now this traffic is going through the ISP 1. And that is because if we check the routing table, now the backup PBR ISP 2 is the one that is active. As soon as we enable this interface, RouterOS is going to know that this ISP is back again and is going to update the routing table dynamically. So you can see that this is active now. And if we start sending traffic again, this is going to travel through the Ether 2. We have configured from scratch policy-based routing in RouterOS 7. I hope the video has been informative for you, and I hope to see you in the next one. Thank you.